Welcome to this FP2 video on modulus inequalities. So basically you need to be able to solve inequalities that include the modulus sign. Now just like when you did this, just actually solving equations including a modulus sign, it's often useful to sketch the graph, okay? So you can see what's happening. But other than that, this will be generally nothing too new for you. So I think what we'll do is we'll jump straight into the first example. So here we have the modulus of x squared minus 5x, and that is going to be less than 6. So what I'm going to do is I'm going to sketch two graphs. I'm going to sketch y equals the modulus of x squared minus 5x and y equals 6. So the y equals 6 graph, that's nice and easy. That's just going to be a horizontal line going through 6 on that, y-axis. But the x squared minus 5x, that again is also very simple. So if we first consider just y equals x squared minus 5x, factorising it, I get with x outside the brackets and x minus 5 inside the brackets, and when y is equal to 0, x will be 0 or x is 5. So let's just kind of mark on 2 points there, and this is going to be like a U shape because it's an x squared graph. However, we've got that modulus sign, which means that anything below the x-axis won't happen, okay? All those negative values will become positive values. So I'm left with a graph that looks something like this. So it's going down towards the 0, and then on the other side symmetrical, going down towards the 5. But then in between I get this almost like an N shape. So here's my sketch now of the two graphs. What I need to do now is find these two values here, the points of intersection, or the kind of critical values, if you will, because it's an inequality. So we're going to look at the critical values when x squared minus 5x inside the modulus sign equals 6. So we're finding the critical values. Okay, so sorry, there should be 4 values. So here, 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 and here. So if I do these outside ones first of all, these are part of the normal graph, not affected by the modulus sign. So that means that if I do x squared minus 5x equals 6, I should get the values of these 2 points here. So this is x squared minus 5x minus 6 equals 0. This should factorize to x plus 1 and x minus 6. Let's check that. X squared minus 6x plus 1x is minus 5x, and 1 times minus 6 is minus 6. So x equals minus 1 or x equals plus 6. And that does make sense on a graph. This is going to be a negative x value, and this is going to be an x value above 5. So that makes sense. Now let's go ahead and find these two values. So these two values happen after the modulus sign has affected our graph. Okay, that means that this modulus sign has changed a negative value into a positive value. To find those critical values, we need to do x squared minus 5x and change that into a negative. So this is what we've got. So we've got minus x squared plus 5x equals 6. Taking it to the other side, we've got x squared minus 5x plus 6. Now again, in this case, this will factorize. So this is x squared minus 3x minus 2x gives me minus 5x, and minus 2 times minus 3 gives me plus 6. So x equals 2 or x equals 3. And those both seem like relatively correct values for these two. Now we can go ahead, now we've worked out all our critical values, which I've just marked on the graph here, and we can go ahead and work out when this modulus is less than 6. So it's below 6, so this graph is below 6 between -1 and 2, and then below 6 between 3 and 6. So this means that it's -1 x 2 or 3 and 6. Okay, and in set form that will just be like this. Alternatively, it could be like this. Okay, that last one generally done by other exam boards, most notably WJEC like to use this notation. But here we have it. So here's the first example, nice, straightforward. It's just the introduction of the modulus sign. And, in this case, it is about solving for the critical values and then using your graph. So it's probably easier in a lot of cases to draw the graph, sketch the graph first. Okay, find the critical values and then find the solution at the end. Let's have a look at another example. So here we have our next example, modulus of 4x, then plus x is greater than or equal to 15. Okay, now as it stands, sketching this and this separately is not as easy as if I rearrange it. So if I rearrange it and get this, is far easier to sketch. So now I'm sketching the modulus of 4x and I'm sketching 15 minus x. Both of these graphs now are nice and easy to sketch. So I went ahead and sketched these quickly. So we've got 15 minus x, which is this red graph, and the modulus of 4x is this green graph here. Okay, nice and straightforward. We've got two intersection points here. So we need to go ahead and find our critical values. Don't need the bottom of this graph, so I can get rid of that, create a little bit more room. So critical values. Now, this one is going to be created by the modulus sign effect in my graph. So for this one, it's going to be minus 4x equaling 15 minus x. So that's going to be, if I take the minus 4x over to the other side, I get 3x equals minus 15. So x equals negative 5. And then the other one is going to be created when the 4x is positive. So again, take the minus x to the other side, gives me 5x equals 15. x equals 3. So these are my two critical values. Now back to the inequality, we want when the modulus is greater than or equal to this graph. So we want when the green is above or equal to the red line. So it's above the red line on the left of this value. So going to the left here, and it's above the red line going to the right of this intersection point. Okay, so that means that x is less than or equal to minus 5, or x is greater than or equal to 3. And then alternative form for that is set form, or like I said, some of the other examples generally favor this form. Square brackets means also equals to. So this is, you know, from minus infinity up to equaling this minus 5. And this one from 3, including 3, all the way up to infinity. Okay, so this one generally not used in Edexcel. I haven't seen it used, to be honest, in Edexcel, but it is a valid method. This is the set form that's usually used with Edexcel. Alternatively, you know, just as an inequality there. So that was the second example, and I think you'll agree, you know, it's quite an easy one. This one just showing you because sometimes it's easier to rearrange what you've got before you sketch. Now let's have a look at the third and final example, and here it is. So again, you know, we're going to approach this in the same way as the others. So we're going to sketch the modulus of x squared minus 2 and 2x. And here we have the two graphs sketched. So this one I've got here in red and this one in green. Okay. And we're going to have 2 points of intersection. So let's start off with the standard point of intersection, this one. This is going to be on the part of the graph that the modulus sign doesn't affect. So critical values, and we're going to have x squared minus 2 equals 2x. So x squared minus 2x minus 2 equals 0. Then using the quadratic formula, we get that x equals 1 plus root 3 or 1 minus root 3. So I can just write that as plus or minus root 3. So I've got that, but that isn't telling the full story, is it? Because both of these answers, the negative answer is a negative value. Now, this green graph doesn't cross this graph anywhere on the negative side of the x-axis, does it? So this 1 minus root 3 isn't actually a correct point of intersection. But I'll deal with that in a moment. Now the other critical value happens when the modulus sign does affect my graph. So that is this being with the minus outside now. So that is going to give me x squared minus 2, sorry, not minus 2x, plus 2x minus 2. And that gives me x equals minus 1 plus or minus root 3. And again, both of these values won't work because minus 1 minus root 3 is going to be a negative value, and we've already established that there's no point of intersection there. So this is where I have to be careful, and what I have to do is pick the values that actually work. So it's 1 plus root 3, and x is minus 1 plus root 3. And that is then shown on the graph. So this value here is 1 plus root 3, whereas this value is minus 1 plus root 3. So these are my critical values. Now we go back to the inequality. And we want when the modulus part of the graph, the modulus graph, is less than the linear graph. So we want when the red graph is smaller than the green graph. And that is going to happen to the right of this intersection point and to the left of this intersection point. So we're going to have when x is between 1 plus root 3 and minus 1 plus root 3. So that now is going to satisfy it, isn't it? It's going to be the red is below the green between these two critical values. Now it wants it in set notation. So put in this in set notation, we get effectively the same thing, just with a little bit of additional brackets and stuff. Okay, so now we have it in set notation and this question is complete. So that is the 3 examples to help you with the modulus graphs, modulus inequalities. If you found this video useful so far, hit that like button. If you're yet to subscribe, hit the subscribe button. And if you're willing and able to help me out financially, hit that join button. Otherwise, let's get into the questions. So I have 4 questions for you to have a go at. As always, I'll go through the answers afterwards. So pause the video now. Welcome back. So hopefully you've had a chance to have a go at these questions. Now let's see how you did. So with this inequality, the easiest way to be able to sketch them is to rearrange it. And we can take up that x plus 1 because that x is in the modulus sign is always positive. So this is always positive. So we can multiply that. We know we're multiplying by a positive value. So the sign, the inequality isn't going to change. But now we're able to sketch 3 minus x and sketch 2 brackets mod x plus 1. So here is a quick sketch of the graphs. So 3 minus x, nice and easy, goes through 3 on the y-axis, actually hits 3 on the x-axis as well. And it's a negative x, negative 1 gradient. This one is the same as the mod x graph, but we've got 2 times that mod x, so it's twice as steep. And then, you know, it's crossing at 2 on the y-axis. So there we have it. We're going to have 2 points of intersection, one on the regular graph not affected by the modulus sign, and one on the part of the graph that is affected by the modulus sign. So let's go ahead and solve these. So we've got 3 minus x equals, and then 2 brackets, now it's minus x plus 1 for the first one, and that'll be 3 minus x equals minus 2x plus 2. So taking the 2x to the other side, that'll give me x, and taking the 3 to the side, that gives me minus 1. So my first critical value is x equals minus 1 here. That makes sense. Now for this intersection point is the regular part of the graph unaffected by the modulus sign. So that is 3 minus x equals 2 brackets x plus 1. So 2x plus 2, 3 minus x. So take the x's to the right, take the 2 to the left, we get this. So x equals 1/3. So this value over here is 1/3. Now, going back up to our rearranged inequality, we want when this one, which is the green line, is above the red line. So it's above the red line between the -1 and the third. So that means that x is between -1 and 1/3, and we want it in set notation. Sorry, I'm terrible with those squiggly brackets. That one's better. And there we have it in set notation. And that is question 1 complete. Now question 2. Okay, so we've got two graphs here and here. Now this one's obviously dead easy to draw. Goes through the one on the y-axis and actually goes through one on the x-axis as well. So nice, easy to draw. This one a little bit more challenging. So first let's look at what's happening with this. So if I change the top to add 2 minus 2 to it, so it stays the same. So then this is x plus 2 over x plus 2 minus 2 over x plus 2. This is just 1, so we get 1 minus 2 over x plus 2. So this graph has a vertical asymptote at -2. So I'll just pop one on there, call this -2, that will be 0. Okay, and we're expecting a reciprocal graph here. So we've got our reciprocal graph and we've got it increasing by 1. So it should have a horizontal asymptote of 1. So this is looking like this here for this one. And then when we go to this side, now normally this will look something like this. Actually, it goes through the 0. Redraw that through the 0. Because when x is 0, we get 2 divided by 2, which is 1. 1 minus 1 is 0. So this is what we've got. But this part of the graph is going to be affected by this modulus. So this part of the graph is going to go up that way. Okay, so it's actually going to be up like this, like this. So then this part of the graph I can effectively rub out. Okay, so that's that modulus part of the graph drawn. And as you can see, you know, it's not always straightforward to draw these. You might need to do a little bit of work, but you know, if you take it step by step and just approach it in a logical manner, you'll always get the graph drawn there. Now finally, I did that one in black, but let's do the 1 minus x graph. So it goes through the 1 like so. Sorry. So I've got something like that. So those are my two graphs. And as we can see here, we've got 1, 2, 3 intersection points. Okay, so now let's go ahead and work out the critical values. Now I'm just gonna get rid of a little bit of, make a bit more room, and there we go. So it's gonna, the intersection points are gonna be the points where here and here is unaffected by the modulus sign, and then this point is going to be the one affected by the modulus sign. So let's go ahead and work out the ones unaffected by the modulus sign first. So that gives me that. So x is 1 minus x multiplied by x plus 2. So expanding this, we get x plus 2 minus x squared minus 2x. So that is x squared. We got minus 1x, so plus 2x minus 2 equals 0. And then using formula, okay, obviously you put down the values of the formula. Don't just jump straight to the answer as I am doing. So we get 1 plus or minus root 3. Okay, so that is, 0.73 and minus 2.73. And both of those seem correct. 0.73 is after the 0. So here, and minus 2.73, this one is below the minus 2. So both of those seem correct. Now we need to find this value, and this one is when the modulus sign affects that graph. So we're looking at minus x over x plus 2 equals 1 minus x. Okay, so I'll just swap these around. So I get x minus 1 equals x over x plus 2. And that is x minus 1, x plus 2 equals x. So it gives me x squared plus 2x minus 1x, so plus x minus 2 equals x. So this is x squared minus 2 equals 0. So that is x squared equals 2, or x equals plus or minus root 2. Okay, now both of these values aren't going to work because we only want one more value, this one. And this value is between 0 and minus 2. So the positive root 2 won't work. So let me just get rid of this bit. So we want, therefore, x equals minus root 2. So those are my three critical values. Now let's go ahead and jump back to the inequality. So we want then this modulus graph, which is in black, is less than the red graph. Okay, so it's going to be, I'll pop these on in green, it's going to be smaller than the red graph from this critical value to the left. It's going to be smaller than the red graph from this critical value to the right, and this critical value here to the left. Okay, so what we're looking at is when x is less than minus 1 minus root 3, or when x is between minus root 2 x and minus 1 plus root 3. Okay, and then putting this in set notation, we get x is less than minus 1 minus root 3. Put my squiggly brackets on. U for or and x is between root 2, minus root 2 I should say, and minus 1 plus root 3, and squiggly brackets on at the end. And there we have it. That's question 2 complete. Now let's have a look at question 3. So our first step is to sketch both of these graphs, which I'll do now. And there we have it. So we've got our modulus graph here drawn, and then obviously the bottom bit is reflected above. That means it's an intersection point. They both hit the y-axis at 6. So there's one, and then I think there's one the other side because the peak is this side. But, you know, that might be that it might be to this side. So we'll see once we solve this. So first of all, let's find these points of intersection. So that is the critical values. So 2x squared plus x minus 6 equals 6 minus 3x. Now this is the regular part of the graph, unaffected by the modulus sign, so that will give us this point and this point. So that's 2x squared plus 4x equals 0. Sorry, minus 6, isn't it? So it's minus 12 equals 0. Dividing through by 2, we get x squared plus 2x minus 6 equals 0. And this won't factorize, so use the quadratic formula and we get minus 1 plus or minus root 7. Okay, and that gives me a value of 1.65, which is in between 1.5 and 2. And then the other value should be a negative value less than minus 2. And minus 1 minus root 7 gives me minus 3.65, which again makes sense for this one. Now let's go ahead and find the other critical values. So that is when the modulus sign affected my graph. So putting a minus sign in front of it. So we get minus 2x. Well, actually, we'll just take it all to the other side. And we get 6 minus 3x plus 2x squared plus x minus 6. So that is 2x squared minus 2x. Just equals 0. So that means that we can divide by 2, and then we got x squared minus x, which is x brackets x minus 1. So x equals 0, which we know is true, and x equals 1. Okay, so we knew this one was x equals 0 and x equals 1, so it was definitely an intersection point on this side. So now I've got my 4 intersection points, I can go back to here, and I want when this modulus graph is greater than this linear graph here. So when the red is above the green. So the red is above the green to the left of this. So I'll mark these on. Let's use a nice kind of pinky colour. So to the left there, the red is above to the right of that one and to the left of that one. And then the red is above to the right of that one. So we've got 3 regions in total. So x is less than minus 1 minus root 7, or is between 0 and minus 1 plus root 7, or it's greater than Oh, no, sorry. That's not that one, is it? It's between 0 and 1, and then it's greater than -1 plus root 7, because these were the two outside ones, and the 0 and 1 were here. So those are my three regions there. That is question 3 complete. Now let's move on to the final question, number 4. So here we have our question. Let's jump straight into sketching them. So x squared minus 4 in the modulus is going to come down on both sides symmetrically about the 0, and then it's going to go up and down. And this is going to be 2, and this is -2, and this is going to be 4. So that is my modulus of x squared minus 4. Now next I need to do the modulus of 2x minus 1. So it's going to be a positive graph. Okay. Coming down, hitting here, hitting at x equals a half there. And then this point is going to bounce off and go through the 1. Something like that. Now, obviously, these will reach there. So we've got now 4 points of intersection. 1, 2, 3, 4. All are going to be valid. So let's go ahead now and find these points of intersection. So critical values. So x squared minus 4 equals 2x minus 1. So x squared minus 2x minus 3 equals 0. So this factorizes, doesn't it? So minus 3 plus 1. Let me just double check. X squared, 1x, take away 3x is minus 2x and minus 3. So x equals 3 or x equals minus 1. Those are my points of intersection there. And then my second set of intersection points will come from, making one of them negative. Because if I made them both negative, then it wouldn't change a thing, would it? So x squared minus 4 equals minus 2x plus 1. So x squared plus 2x minus 5 equals 0. Now this one won't factorize, so here I'll use the formula, and this is going to give me that x is minus 1 plus or minus root 6. Okay, and it's not quite as simple as the other one when you can see which part of the modulus sign is affecting it, because this one, the 3 and the minus 1, gives me this point and this point, and this one gives me this point and this point. So it's not quite as simple as when it's just a single modulus in your equation to solve. Now we want to go back to this, so it's when this one is greater than this one. So this is the red graph, so when the red is above the green. So again, I'll go on to my graph. So the red is above my green when it goes anywhere to the left here. It's to the right of this one, to the left of this one, and to the right of this one. So we've got 3 regions in total. So x is less than minus 1 minus root 6, or x is going to be between minus 1 and minus 1 plus root 6, and then x is going to be greater than 3 for the final one. So there I have my 3 regions. And that, folks, is the end of the video. So hopefully you enjoyed it, or at the very least found it useful. If you did, don't forget to hit that like button, subscribe if you're yet to subscribe, and hit the join button if you're willing and able to help me out financially. Otherwise, I'll catch you in another video. Oh, and comment down below. Okay, anything you want to comment down below.